This is our first experience with roots other than square roots. There are lots of other different types of roots, and this example right here would be called the nth root, where n is representing what would be the root in this example. So we call it an nth root. And the roots that you've dealt with so far are the square roots. So for example, this would say the square root of a. But since there's no number inside here and there is one here, we typically have an understood root of 2. That's why we call it the square root, because what number squared would give you a in this example. But there are lots of other roots. You could find the cube root of a, so what number used 3 times is a. Or you can find the 4th root, what number used 4 times is a. You could find the 100th root, although I don't know anyone who would want that, but you could find what number used 100 times is a. And there are 2 different possible answers. You could have a real number or an imaginary number, and I know we've talked briefly about imaginary numbers. You will experience them when you get to Algebra 2. Let's look at some examples. We want to simplify the expression, meaning to reduce it if you can. This is saying what number used 3 times is 64. So I want you to train your brain not to see this to the root symbol and automatically assume it's 8, because they're asking you what number used 3 times is 64. Well, the answer is 4, because 4 to the 3rd is 64. This wants to know what number used 4 times is 81. So that's 3, because 3 to the 4th is 81. And you'll get more familiar with these as you experience in them. This is the first time you're experiencing them, so it might not come as quick as maybe it comes for me. We can also write nth roots other than up here with the symbol, with the root symbol. We can write them with exponents. And the nth root of a positive number a, which is our variable, can be written with a base of a and an exponent of 1 over n. So the way that would look up top here would be the root sign with the n inside of it, but we can also write it with an exponent. So a, the nth root of a, could be written as a to the 1 over n. And I'll explain where the 1 comes from in a moment, but when I think of plants, this is how I remember. I've always got these catchy devices to remember things with exponents and radicals. When I think of a plant, the root is on the bottom, and so the nth root means that the n goes on the bottom. What that would mean in numbers, let's say I want 81, I want the 4th root of 81, that would be 81 to the 1/4. Let's check out some examples, and I'll explain where that 1 comes into play right now. I've got the 400 to the 1/2 power. Well, the root is on the bottom, so in the fraction, the 2 is going to be my root, and the 1 is going to be the exponent. So I can rewrite that as the square root of 400, or the second root of 400, and then raise that to the 1st power. Now, that doesn't really do anything for now, but it will in a moment. And if you don't want to write the 2 here, you don't have to, because it's understood, as I said earlier, that it's a 2. So, order of operations, do the square root of 400, which is 20, and 20 to the 1st is just simply 20. So, done. Let's move on to the next question. 243 to the 1/5, that means that they want the 5th root of 243 because the root is on the bottom to the 1st power. So 243 to the 5th, well, what number times itself, used 5 times, is 243? The answer is 3. And so 3 to the 1st is just simply 3. Now, if you understand where I got 3, you don't have to do all this stuff that I just crossed out in green. You can just write 3. But I'm putting this here for those of you that aren't really understanding where the 3 comes from. All right, let's look at some more advanced questions. All right, here's where we use that fraction in a more advanced way. So we're still going to rewrite it, and the root is still on the bottom, so this is saying the fourth root of 16. But what they want us to do after that is they want us to raise it to the third power. So we're going to take that and we're going to raise it to the third power once we've done that. So the numerator tells you what the final power is, and the denominator, again, is the root. So the fourth root of 16 is 2, and 2 to the third equals 8. Over in example B, we want the third root of 27 raised to the fourth power. The root is always on the bottom, and the third root of 27 is 3, and 3 to the fourth is 81. The radius r of a sphere is given by the equation r equals 3v over 4 pi to the 1/3 power, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Use 3.14 for pi. So we definitely want to have our calculators powered up. Follow along with me. Don't just let me do it. Follow along with your calculator. And let's plug in what we know. Okay, so we plug in what we know, and now we have this big bundle of math inside here, and then we'll get this number, and then we'll find out what number to the third power, or to the 1/3 power, equals r. Okay, so that's 339 on the top, 12.56 on the bottom. Okay, now when I type this in my calculator, 339 divided by 12.56, I get 26.9904459. I'm going to round that to 27 because they told me to round. Remember, don't round unless they say to, but they actually told us to. And so I want 27 to the 1/3 power. So that is the third root of 27 to the first, right? Because that's what the numerator tells me to do, but anything to the first is itself. And the cube root of 27 is 3. So the answer is 3, and they want the radius, so that would be 3 feet. All right, this practice section is all for you. Show me what you got. Show me that you can do it. Show yourself that you can do it. And pause the video, and when you're ready, play, and I'll put the answers up. All right, if you got any wrong and you don't understand why you got it wrong, write it down and ask me when you see me in class.